Okay, now this problem, the number 4, was just doing the calculus, and this was the calculus one. But you need to show me work. You can't just write down what it is. You need to tell me what derivative you're taking. So if I want to solve for the velocity, then the velocity is the derivative of x with respect to time, or the derivative of y with respect to time if the motion was in the vertical direction. Or I could just use the generic s for displacement and say the velocity is the derivative of displacement with respect to time. So in this one, if I look at my x, I want to take the derivative of that. So this is 3t4 plus t to the third minus 6t. So when I take the derivative, the 4 comes in front, and I drop the exponent by 1. So it's going to be 12t cubed. The next term is going to be, I take the 3 and bring it in front, and it's going to be 3t squared. So it's going to be 3t squared, and then the derivative of minus 6t is minus 6. So that's the formula. That's the velocity with respect to time. That's the equation. And I asked you, what's the answer at 2 seconds? So just put 2 seconds in there. So you're going to have 12t cubed plus 3t squared minus 6. And so I'm going to put in 2 there and there. And I know that my units for velocity will be meters per second. So the answer to that came out to be 102 meters per second. So that was the velocity. Now the acceleration is the second derivative of the x equation, or the first derivative of the velocity equation. So I just wrote down the velocity equation. So we'll take the derivative of the velocity equation with respect to time. So you've got the derivative of this would be 36t squared. So 36t squared plus, when I bring the 2 in front, it's going to be 6t, and the derivative of a constant is 0. Remember what a derivative means. A derivative is measuring the change. So if it's a constant, it's not changing with time. It's always that number. So we just plug in the numbers, 36t squared plus 6t, and we put in 2, because I wanted to know what it was at 2, and the answer came out to be 156 meters per second squared. So those are your answers for that one. Any questions on that? All right, so now, and look, there's not an awful lot of work for each of these problems. Like, even with me putting like 3 or 4 problems on one page, you have plenty of room to do the work. Now the next one, it says a harmonic oscillator follows the equation, and they're giving you the second derivative of x with respect to time. That's the same thing as acceleration. So I'm just going to write it down here as a equals minus 3.6x. So that's my acceleration. Because the second derivative of x with respect to time is acceleration. And they also are giving me in the problem that k is 9 newtons per meter. And the question is, what is the period? So the period will be in seconds. Now, we also have, like, I could have asked you what the angular frequency or what the frequency was. I know in one version, I think it was something different than this. But in this particular problem, what the force that's causing the movement of a object that's in simple harmonic motion is the spring force. So I know that the spring force is going to equal ma. So the spring force equals ma. Well, the formula for the spring force is minus kx. So minus kx is going to equal m, and I'm going to replace a with what I said A was. So actually, I like to have my number in front, so let me write this as minus 3.6 mx, okay, because I've got the minus 3.6x, and then there's an m. So there's my a, and there's the m. So now I have that for my equation. Notice that both sides are negative, so if I multiply through by a -1, they're now both positive. Also, both sides have an x, so I can cancel out the x's. And now I have a relationship for what k is in terms of m. So actually, in solving this, if I were solving for the angular frequency, I don't even need to know that k is 9 newtons per meter. I don't even need to know it. This was that problem that actually had 3 parts, and I just picked one of the 3. I might have needed the 9 to solve for something else, but I don't need it here because if I'm solving for t, my formula is 2 pi square root of m over k. That's my formula for the period of something in simple harmonic motion. So I'm going to write that as 2 pi square root, and I'm going to write m up here, but I'm going to replace the k with 3.6 m. So if I replace that with 3.6 m, now the m's cancel out. So I didn't even need to know what the value of k was to solve this. It's just going to be 2 times pi times the square root of 1 over 3.6. And that would give you the answer. And so the period in this problem came out to be 3.31 seconds. 3.31 seconds. And that's it. Any questions with that one? Okay, so we did 4, we did 5,